Every number you have ever heard about the food on your plate came out of a computer, not out of a farm. Somebody modeled what a vegan eats and what a heavy meat eater eats, then hit run. Nobody checked whether those models survive contact with reality. That is not a small footnote. The most repeated environmental advice of your lifetime was built on assumptions rather than measurements. So what happens when somebody finally counts? Here is what you are about to find out. Why two steaks that look identical carry completely different environmental bills. Why the gas your dinner releases matters more than the amount. What tens of thousands of real diets reveal once the modeling stops. And the one number that survived everything thrown at it. Before any of that, you need to feel the size of this thing. Look at whatever you ate today. A sandwich. A bowl of pasta. Where was all of that before it was food? Growing and moving and eating food is the largest thing our species does to this planet. Bigger than every car on the road. Around a third of all the greenhouse gas humans release comes from getting dinner onto plates. Food also drinks roughly 7/10 of the fresh water people use. Almost none of that is showers or swimming pools. It is fields. And about 3/4 of the planet's ice-free land has been reshaped by human hands. So the real question is not whether your dinner carries a cost. It is who pays it and how much. The label on a packet of mints tells you about money. It says nothing about the land or water or gas behind it. There is a second receipt attached to everything you eat. You have simply never been handed it. That receipt has a name. Scientists call it a life cycle assessment. It is the full bill for a food from seed in the soil to wrapper in your bin. Picture a single block of cheddar. Somebody has to count the grass the cow ate. The diesel burned cutting that grass, the fertilizer on the field, the electricity in the dairy and the fuel in the lorry. This way of counting was not invented by climate scientists. It appeared in the late 1960s when a soft drink company wanted to settle an argument. Were glass bottles or plastic containers actually better? You cannot answer that by staring at a bottle. So they traced it backwards. Mining, melting, shipping, washing. That habit of chasing a product back down its supply chain is the ancestor of every food footprint figure since. Now stretch that from one bottle to everything a person eats in a year. That is the job the research behind this video took on, which forces an uncomfortable admission. There is no single environmental cost. There are 5. Think of every food as carrying 5 separate price tags. Carbon, land, water, nutrient pollution, and harm to wild species. A food can be cheap on one tag and brutally expensive on the next. The carbon tag is the one you already know. It counts the gas released to get that food to you, but it hides something almost nobody notices. Not all of that gas is carbon dioxide. The land tag is simpler and stranger. Every food occupies ground somewhere for a season. Some crops rent a small patch. An animal needs pasture stretching to the horizon, plus a second field growing its dinner. That second field is the part people miss. An animal is not a machine that makes food out of nothing. It turns a lot of plant food into a little animal food. Most of the crop just keeps the animal alive. The water tag counts what the crop drank rather than what came out of your tap. Fields in dry countries pull irrigation from rivers and underground stores that people and wildlife are also queuing for. The 4th tag has an ugly name and a vivid symptom: eutrophication. Fertilizer and manure wash off farmland into rivers. The water suddenly holds far too much food and erupts with green algae. Then it dies and rots and strips the oxygen out underneath. The 5th tag is the hardest to feel. It measures how far your food pushes wild animals toward vanishing. Not by hunting them, by taking their address. Forest becomes field, and whatever lived there has nowhere to go. Hold on to those 5 tags because they refuse to move together. Now back to the thing hiding inside the carbon number. Your dinner does not release 1 gas. It releases 3 and they behave nothing alike. The first is methane, and it comes almost entirely out of cows and sheep. A cow is a walking fermentation tank. The microbes doing the digesting make gas that the animal burps out steadily all day long. Methane does not linger for centuries the way carbon dioxide does. It fades in roughly a decade. But while it is up there, it traps heat far more aggressively than the same weight of carbon dioxide. The second gas is nitrous oxide, and it rises mostly off fertilizer. Spread nitrogen on a field and soil microbes turn part of it into a gas that drifts up and stays for over a century. Here is what makes that strange. Most of that fertilizer is not growing your food. It is growing food for animals that will later become your food. You are eating a field at second hand. The third is ordinary carbon dioxide from tractors and lorries, and factories and cleared forest. 3 gases with 3 completely different origins. Which means 2 people with an identical carbon total can be doing very different kinds of damage. Now stand in front of a chilled cabinet and look at 2 steaks. Same weight, same color, same shelf. Everything about that display makes them look interchangeable. Their environmental bills can sit several times apart. Why? One animal may have been raised on land cleared from forest in a hot country. The other on old pasture with different feed and a shorter journey. Identical at the till, wildly different history behind it. If you enjoy having the hidden half of your dinner explained, then subscribe. It costs you nothing, and the second receipt keeps arriving. Because that shelf raises the question this whole video is built around. If the damage done by a food depends that much on how and where it was made, does your personal choice even matter? Or does farming method wash the whole thing out? That is not a rhetorical flourish. It is the exact hole in the science this research was designed to fall into. Every earlier estimate had quietly used one average value per food. One number for beef, the same trick for milk and rice and everything else, as if every farm on Earth worked the same way. Nobody knew whether the famous diet differences would still be standing once that fiction was removed. There is a second fiction worth killing first. The one where the world splits neatly into vegans and everybody else. That framing has shaped this argument for decades, and it is simply wrong. Eating meat is not a switch, it is a dial. So this research split meat eaters into 3 settings on that dial. Light, middling, heavy. The light end sits under about 50 grams a day, which is roughly 1 small sausage. Where would you land on that dial? Count the meals you ate last week and be honest. Most people guess low. Treating meat as a spectrum changes what an answer can even look like. Because if the dial matters, then the useful question stops being whether you should go vegan. It becomes how far you are willing to move along it. Governments have started asking the same thing. The United Kingdom has written emission cuts of more than 3/4 by 2035 into actual law. It is also promised to halt biodiversity loss by the end of this decade, legal commitments rather than slogans. And the comfortable solution does not get you there. Better technology, less waste and higher yields together shave off only around 1/7 of food emissions. Real progress, nowhere near enough alone. Which leaves the awkward lever nobody wants to pull. What people actually put on their plates. And that is where the study behind this video finally walks in. Back in the 1990s, a large health project started signing people up right across Britain, tens of thousands of adults, and it did something unusual on purpose. It advertised in vegetarian magazines and mailed vegetarian societies directly. That is why this data set holds thousands of vegans and vegetarians instead of the handful you normally scrape together, around 2,000 vegans alone. Everyone filled in a long questionnaire about food. Not what you ate yesterday, but what you usually ate across an entire year. Hundreds of separate items: bread, salmon, peaches, biscuits. Then that was bolted onto something enormous. Hundreds of farm-level environmental studies covering tens of thousands of real farms across more than 100 countries. Measured ground rather than modeled ground. Composite foods were the tricky part. What is really inside a ready meal or a chocolate biscuit? So they matched them against thousands of genuine products pulled off British supermarket shelves, ingredient by ingredient. And then the clever bit. Instead of picking one average value for beef, they ran the entire calculation 1,000 times over. Each run rolled the dice on which real farm each mouthful had come from. Every diet was also leveled to the same daily calories and adjusted for age and sex. Meat eaters simply ate more food overall. The comparison had to be plate against plate rather than appetite against appetite. So what happened when the dice stopped rolling? The answer barely moved. A vegan diet came out at roughly a quarter of the climate cost of a heavy meat-eating diet. 4 vegan dinners for the price of 1. And you did not have to go all the way to see it. The lightest meat eaters were already down to a bit over half on carbon dioxide without giving up meat. The dial was doing real work. The gases split the way you would now expect. Heavy meat eaters produced around 15 times the methane of vegans, which is the widest gap in the whole study. Nitrous oxide came in near 3.5 times, and that one traces back to fertilizer. Land told the same story. A vegan diet used about a quarter of the ground a heavy meat-eating diet needed for the same calories. Water was the tag where the two came closest at roughly half and also the least certain. Nutrient pollution followed carbon almost exactly at around a quarter. Harm to wild species came in near a third, with the widest uncertainty of all. For vegetarians, the range stretched far enough that no real difference cannot be ruled out. So did your choice survive the chaos of real farms? It did. All 5 tags pointed the same direction after 1,000 rolls of the dice. Farming method matters enormously, and it still does not erase the gap between diets. And here's the twist. When the calorie leveling was taken away and real appetites were used, the gap got wider rather than narrower. On methane, the vegan figure fell to about a 20th of a heavy meat eater's. Scaled up to a whole country, the numbers turned physical. British adult diets add up to roughly 120 million tons of carbon dioxide equivalent a year. A completely separate database landed near 113 million. Those diets also occupy around 230,000 square kilometers of farmland. That is an area about the size of the United Kingdom itself. The water works out as 1 cube nearly 2.5 kilometers on every side. And the pressure on wild species comes out at about 1 vertebrate species pushed toward extinction every 17 years from British diets alone. 1 species. From what one country eats for dinner. This is not a British quirk. A French study found vegan diets at roughly a quarter of meat-eater emissions, which almost exactly matches. An American one put vegetarians near 7/10 of everyone else. The full citation sits in the description. One honest caveat. Nobody here was handed a diet and told to follow it. These are people who already ate the way they ate. The groups also differed in age and in how much they ate overall, which is why everything was leveled to the same calories. What lands hardest is not the arithmetic. It is that your dinner is probably the largest environmental decision you make in an average day, and almost nobody experiences it as a decision. It feels like appetite. It behaves like policy. The receipt was always attached. It was just never printed. The only real choice you have is whether you read it before the meal or long after somebody else has paid it.